Okay, and so for our 7.3 lesson, this is in chapter 7, which we do integration techniques. Thus far, we have talked about whether or not an integral would just be a rule that we would know, so memorizing some of our rules. 2, we tried simplifying it with algebra or trig or anything from pre-calculus, maybe an identity, maybe doing long division or even FOIL. But if those things don't work, we tried U sub. And after U sub, we tried integration by parts. So here we are with our kind of 5th step in the flowchart. And now I want to remind you, something I noticed in our last assessment is that while we made the flowchart to kind of, usually that's the way it would work. We would want to try step 1, then step 2, then step 3. So we want to try, is it something I recognize immediately? And step 2, is it something I can simplify? It doesn't necessarily mean that that is the easiest way to go about it. For example, we had, and I'll just put it on the side over here, in our last assessment we had something that looked like, I'll just say 10 minus x to the 4th power. And a lot of you actually multiplied that out, either by straight up multiplying it out or by using Pascal's triangle, when instead this would have been really easy to do a U sub with. So I want to remind you, as you're going through the flowchart of options, integrating trig functions, these methods we're going to talk about today, being our 5th option, know that the flowchart is not necessarily the order in which you should try things all the time. Sometimes one step will be easier than doing another step. So in this case, doing a U sub where u equaled 10 minus x and du equaled negative dx was a lot easier than multiplying it all out. So I just want to encourage you to think about the flowchart as a suggestion and know that you'll have to do a lot of practice to know which of the methods will be most efficient to use on a time test. But today let's add a couple more strategies to your tool belt. And so there are a bunch of types that you'll see here. We're going to start with type 1, but I want you to start to categorize the types as you go along. Is this something I need to use a trig identity for, or is this something where I eventually would like to do a U sub? And those will kind of be our 2 real categories, just with different setups. So type 1 is where we have a sine or a cosine function to an odd power. And this is going to fall under our I want to do a U sub eventually, okay, category. So I want to, as a step say, separate out one sine or one cosine so that I could change sine cubed into the integral of sine x, sine squared x, dx. Okay, that doesn't look like it's changed. We just use a basic exponent power in reverse. But what this allows us to do is to change this sine squared to a trig identity. Okay, so I could change this to sine of x times 1 minus cosine squared x dx. And this is helpful because if I do a U sub, kind of like we did over here, but a little bit simpler, if I let u be equal to cosine of x, then du will be equal to sine of x dx, which is kind of that extra trig function we have lying outside. So by doing this U sub, we can kind of, this is kind of like a power reduction almost. We've reduced one of the trig functions that was kind of extraneously hanging outside. Once we've made our U sub though, this becomes the integral of 1 minus u squared du. Oh, excuse me, I need a negative. I forgot my negative. Okay. All right, so you can distribute the negative if you would like, but I want to point out one important thing, most common mistake I see. A lot of people will integrate this and they will integrate 1 forgetting that we're integrating with respect to u. So they will write, instead of writing u, they'll write x minus u cubed over 3. So just because this is a 1, don't forget you're integrating with respect to u, not x. Okay? So I'll get negative u minus u cubed over 3 plus c. This is an indefinite integral, so we can't forget about plus c. Finally, because the starting integral was in terms of x, our answer needs to be in terms of x. So my final answer is going to be, well, let's go back. What did I make u equal to? Cosine of x. So this is a plus. I forgot to distribute my negative. Woo! This snow day is really getting to me. So negative cosine of x plus cosine cubed x over 3 plus c. And that is our final answer. Okay. If you'd like to try another one, this will be in the filled notes. It's cosine to the 5th x dx. And again, you're going to pull out one of those cosines and try to do some kind of substitution. You're going to get a cosine to the 4th though, so that's going to mean you might need to do a little bit of algebra or some kind of creative, more complex u sub to get down to a certain power. But once you've done that, your answer should be sine of x minus 2/3 sine cubed x plus sine to the 5th x over 5 plus c. So if you'd like to try to make sure that you got this concept down, I would go ahead and pause the video here and try to work out this problem. See if you can get to this answer. And then let's move on to type 2. Okay. Type 2 also has to do with sine and cosine by themselves, but instead we have that their power is even. In this case, we're going to use the half angle formulas. So for sine squared, I always try to remember it as sine means subtract, match the s's. Sine means subtract in this identity. Cosine squared is the same, but with a plus sign in the middle. Okay, so if you can just memorize these formulas, okay, and then know that sine is subtract, cosine is addition, you'll be good to go. Now, you're like, wow, I've never seen these formulas before. Where did they come from? Well, if you rearrange them just a little bit, they're the double angle identities for cosine of 2x. So I can multiply sine by 2, so 2 sine squared x equals 1 minus cosine of 2x. And then I can do a little addition and subtraction. Cosine of 2x is 1 minus 2 sine squared of x. So hopefully you've seen that identity before. You can do the same thing for cosine squared and you'll get something similar. Okay, so if you've never seen these before, these are just an algebraic manipulation of this double angle identity. Here we call them, since we're kind of dividing this in half here, we have half of the angle we're going to end up with, and we call the half angle formula. While you can derive this every time you need it, I recommend just kind of memorizing this. You will need this for the rest of BC calculus, and multivariable calculus for that matter, if you're going to move on. So let's see how this works. If I just need to integrate sine squared x, I am going to replace sine squared with this formula right here. 1 minus cosine of 2x over 2 dx. And don't forget, you need to double whatever was here before. So if this was 4x, you would end up with 8x in here. Okay, so don't forget doubling whatever was inside the parentheses. I recommend taking out the 1/2 just to make your constants a little bit easier. Okay. Now, if you are not ready to skip this step yet, I still recommend that you do a u sub. I actually recommend that you would evaluate them separately maybe, but you can say 1/2 the integral of 1 dx minus 1/2 the integral of cosine of 2x dx, and then do the u sub over here. U equals 2x, du equals 2 dx. That means we're going to have 1/2 du equals dx, which means we're going to need an extra coefficient on the outside. This one didn't really need that, which is why I recommended separating it, but if you can jump right to this final step without doing the u sub, totally fine. Okay, so I'm going to have 1/2 x from this integral, okay, and then I'm going to have, well, if I do the u sub, I'm going to end up integrating, I guess I'll just show it out. So 1/4 the integral of cosine of u du. I'm going to give myself some more room over here. Alright, so still 1/2 x. The integral of cosine okay, is positive sine, and that's one of those we need to practice a lot because we have the sign in the opposite direction. Okay, sine of u plus c. Remember to replace that u in the end, so 1/2 x minus 1/4 sine of 2x plus c. So what I'm trying to say is if you don't need to make the substitution, if you feel confident enough to come over here and just skip to the final step, feel free. I don't need to see that work. But you must get it right every single time. That this, you need to remember that you are technically in your head doing a u sub. So you will need to change the coefficient on the outside. It will not remain the same as it was before. Okay? All right. With cosine to the 4th x, this one is a little more tricky, worth practicing. I want you to notice though, and I'll give you the answer, but I'll let you work this one out on your own, that cosine to the 4th can be written as cosine squared squared. Okay, this will help us replace it with one of those identities we were talking about earlier. So this is really 1 plus cosine of 2x over 2 squared dx. Okay, maybe you take out the 1/4 if you would like here. So because I'm going to square the denominator, a 1/4 will end up coming out of the integral, but I will still have 1 plus cosine of 2x squared. This will require me to FOIL. I will have to multiply this out. Okay. Because I don't have some kind of other, I can't u sub cosine somehow, I will need to FOIL this out. And so if I do that, this will be the last step I show for this one. I will get 1 plus 2 cosine of 2x plus cosine squared of 2x. Okay. Notice that you can integrate this and this, just like we did up here actually. Okay, so this is not the problem, neither is this. This, however, we still ended up with cosine squared. So you're going to have to use the half angle identity again to do this term. Okay, when you've solved it all out, in the end, you should get 1/4 x plus 1/4 sine of 2x. And I notice as I'm kind of writing this down, I forgot to combine my x's. So feel free to combine the 1/4 and the 1/8 into 3/8 x, okay, plus 1 over 32 sine of 4x plus c. So this 1 over 32 is a weird constant. It will come from you doing the half angle identity again and the u sub. Because when I do a half angle identity with this, I will end up with 1 plus cosine of 4x over 2. So don't forget, you're going to have to double this again, okay? Just to make sure you get there. All right, be very careful, show all your work in this one. Okay, but that's type 2. So again, type 1, sine or cosine has an odd power, and we try to do a u sub by taking one of the sine or cosines off. Here, step type 2 was we had sine or cosine, but this is even, and we used a half angle formula. Okay, so those are the two types we've done so far. Type 3 is where you would have something kind of mixed. And when I say mixed, I mean not just sine and not just cosine. The key here is that one of the powers is odd. Okay? And from that odd power, we're going to take off one of the sine or cosines, so again, we can end up doing a u sub. So type 1 and type 3 are again where we're going to have to peel off one of the functions and then try to do a u sub after we've used our trig identities. So here, I noticed that I have a sine and a cosine multiplied together. The sine power is odd, so that's the one I'm going to take 1 off of. So I will have sine of x, sine squared x, cosine to the 4th x. Okay, this is where we need to make a decision. Do I want to change everything to be in terms of cosine or be in terms of sine? Well, if you think to yourself, I peeled off one sine. Okay, that is going to be a part of du when I do my u sub only if u is equal to cosine. So I want to change everything else except this guy, okay, in terms of cosine, which means I'm going to change not this part, but this part, okay, into 1 minus cosine squared x, cosine to the 4th x dx. Okay, here, so I can do one big u sub. You can either do this before or after, however you would like, but you should distribute the cosines. So I'll have integral, maybe I should put that at the back. If you would like to move this with commutative property to be with the dx, also okay. But I'm going to distribute this cosine to the 4th into these parentheses. So I'll have cosine to the 4th x minus cosine to the 6th x dx. Okay, and here is where I get to do my u sub. I let u equal cosine of x, du equals negative sine x dx. So my integral, I should be using equal signs. I've got to use better notation in these notes. My integral will be equal to negative u to the 4th, I should use parentheses, minus u to the 6th du, which looks a lot easier to evaluate with just a power rule. Let me come over here to the side. Okay, I'll go ahead and distribute the negative, so I'll have the integral of negative u to the 4th plus u to the 6th du. And when I integrate that, I will get negative u to the 5th over 5 plus u to the 7th over 7 plus c. Don't forget plus c, it is a definite integral. We're not totally done yet because I need to go back to be in terms of x, so I got to replace all of my u's. U is equal to cosine x here, so negative cosine of x to the 5th over 5, and I was very parenthetical there. You do not have to write it this way. Not sure why I decided this, but also equivalent. Okay, so type 3, we have a mix sine or cosine, but one of the powers is odd. If one of the powers is odd, I peel one off, specifically from the odd power, peel one trig function off, and then I change my other ones to be able to do a u sub. Whichever one you peel off is the one that's going to be a part of your du. So you want to choose your u accordingly. Okay, but let's say that we are mixed, type 4, but both of them are even. In this case, peeling one trig function off is not going to get us any closer to doing a u sub. We're just going to have extra, like if I pulled out one sine, I would have sine times sine, which it doesn't go well with my trig identity up here, in which I need either a sine squared or a cosine squared. So if both of them are even, I'm just going to go straight to the half angle formulas. In this case, this will be really nice, which we'll see in a second. So it'll look really complicated at first. Let me sub in. So sine squared, sine means subtract, so 1 minus cosine of 2x over 2. And cosine is for addition, 1 plus cosine of 2x over 2 dx. Okay, I could take out the 1/4. And then notice, if I take out that 1/4, this is the difference of perfect squares. So multiplying the numerators together will give me 1 minus cosine squared of 2x dx. And if you need to FOIL it out totally, or multiply it out, whatever you call it, feel free to do that on this side. Notice though, this is cosine squared. We're going to need to do the half angle again. So again, this time I've got 1/4, the integral of 1 minus 1 plus cosine, I got to double the angle that was there, so of 4x over 2 dx. This might be a good time to split up this integral into two parts so I don't have to let them interact. So I'm going to have 1/4 the integral of 1 dx minus 1, maybe I'll pull this out, forgive me for skipping that step, 1/8 the integral of 1 plus cosine of 4x dx. Okay? All right. Again, I'm going to integrate this 1 separately from this. And if you need to show your u sub, go ahead and do that. Pause here and do the u sub so that you can move on to the next step together. But if I integrate this first integral, I will get 1/4 x. If I integrate the 1 here with respect to x, I will get minus 1/8 x. And when I integrate cosine of 4x, I will have an extra 1/4 times this 1/8, and the integral of cosine is sine. So I will have minus 1/32 sine of 4x plus c. Okay, so if you want to take it one more step and totally simplify it, I'm going to have 1/8 x minus 1/32 sine of 4x plus c. Okay, sorry it's a little crooked, but there it is. Okay, final example. Okay, so that was type 4. Sine and cosine, both in the integral, both even. I use the half angle identities. Okay, so hopefully you can start to see a pattern where if I have, regardless of whether I only have sine or I only have cosine, or if I have mixed, if I have odd powers, I'm going to try to do a u sub. If I have even powers only, I'm going to try to do the half angle identities. Okay, so this is where I want you to start categorizing these things in your mind so it's easier to use these rules once we've completely done all the rules. Because remember, we still have 2 sections left after this. Okay, so the last type here, or excuse me, I guess last 2 types. Let's get down, I got type 5. Okay, in this case, we're not dealing with sine or cosine anymore. We're dealing with tangent and secant, or cotangent and cosecant. All right, so we either are going to have one type where the secant or the cosecant has a power that's even. That's important because the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So we're going to want to pull off 2 of those, just like we were trying to do a u sub. Okay, so again, this would be a case, type 5, okay, is where the power on secant or cosecant is even. So for in this example, I am going to leave tangent alone, tangent cubed, but I'm going to split up the secant into 2 parts. Okay, so I almost want to do the u sub, because I know that if I let u equal tangent, du will be secant squared dx, but I need to get rid of this secant squared. So in order to get rid of this, I'm going to use another trig identity. The fact that secant squared is equal to tangent squared x plus 1. So this will start to look like one of the types we did earlier, where I want to distribute this tangent into here. So I'll get tangent, parentheses, tangent to the 5th x plus tangent cubed x, and then secant squared x dx. Okay, now I'm ready for my u sub. I let u equal tangent x, I'm sorry, you can't see that, du equals secant squared x dx. So my integral becomes the integral of u to the 5th plus u cubed du. When I integrate, I use my power rule, u to the 6th over 6th plus u to the 4th over 4 plus c, and in the end I change back to being in terms of x like the original problem asked. So my end answer, since u is equal to tangent of x, is tangent to the 6th x over 6 plus tangent to the 4th x over 4 plus c. So again, this example, I had tangent to some power and secant to an even power. This is where I did my u sub. So again, secant to an even power in this case, a little bit different than the sine and cosine. I wanted to pull out one of those secant squareds and do a u sub. Alright, finally, type 6, last type here. I again have a mixed integral where I have tangent and secant, but the powers on secant or on the powers on everything, but specifically secant and cosecant, are all odd. Okay. In this case, we're going to do a different u sub. We're going to use the fact that the derivative of secant is secant tangent. So I'm going to pull out one from each of them. Again, kind of rewriting my integral in a creative way in order to be able to do a u sub. So I've got tangent squared, secant squared, and then I pulled out one from each. Tangent x, secant x. Okay. This right here is the derivative of secant of x. So I'm going to do a u sub with secant, which means everything needs to be in terms of secant. So I'll have the integral of secant squared x minus 1, secant squared x, and then tangent x, secant x. I'm sorry, I'm being lazy with my parentheses around all of my x's. E, C. Wow, that was bad. Secant x dx. Okay, let's multiply the secant squared into those parentheses right before I'm about to do my u sub. So I'm going to get secant to the 4th x minus secant squared x, and then tangent x, secant x dx. I'm ready for my u sub. Okay, u equals secant x, du equals tangent x, secant x dx. So my integral becomes the integral of u to the 4th minus u squared du. When I integrate, I get u to the 5th over 5 minus u cubed over 3 plus c. Final answer, secant to the 5th x over 5 minus secant cubed x over 3 plus c. Okay. All right, and that is all of the types. Okay, so let's go through it. Let's do a summary one more time. Let me start from the beginning. Type 1, we had just sine or just cosine, and the power was odd. Okay. This, we wanted to end up doing a u sub. Okay, so peel one of those functions off so we can do a u sub. Type 2 was where we had just sine or just cosine and the power was even. We wanted to use a trig identity. And that's where these half-angle identities came in. Type 3, we had mixed sine and cosine, but one of the powers was odd. In that case, we again wanted to do a u sub. So for sine and cosine, if you see that the powers are odd somewhere, you're going to want to do a u sub. Okay? And for sine and cosine, if the powers are even somewhere, or throughout, all of it, not just somewhere, let's say that again. If I have a sine integral, a cosine integral, or a mixed sine and cosine integral, and all the powers are even, I want to do half angle, which is a trig identity. That's what I wrote on the first page. Okay? All right. But then we have type 5 and 6, which had to do with tangent, secant, cotangent, or cosecant. Okay? If I had a mixed integral with tangent and secant, or cotangent and cosecant, and the power on the secant or cosecant was even, I was going to try a u sub. That's the difference between using sine and cosine versus using secant, tangent, cotangent, cosecant. If I have tangent secant or cotangent cosecant and all the powers are odd, I am again going to do a u sub. Okay, so both of these are u sub, just what you're going to u sub differs. So here, I'm going to use sub for tangent or cotangent, depending on what you have. Here, I'm going to use sub for secant or cosecant, depending on what you have. Okay, this will take some practice. There are some pages in your book that will help you figure this out, but if you'll flip to the next page, you'll see that you've got a ton of practice to do. Make sure that you've practiced these and that you check out the filled notes to make sure that you're getting it right. All right.